PreAP PreCalculus, Note Section 1.2, Computations involving function notation. Previous section, we focused on transformations and some parent graphs, how different numbers or negative signs are going to affect the parent graph to make a new graph. And today, we are going to figure out what it means when we do some calculations with the function notation, what the x and y values mean. And we're going to be writing some things down in sentence form, things that you might feel like, well, that's just common sense, but you'll find as you get to know this world more and more, common sense is not as common as you might think. The notation f of x is read f of x. F of x is a notation of the function that represents y. In other words, y is the same thing as f of x. Let's consider the function f of x equals this fella. You should know what this is. This is a parabola. We know that because this is being squared. We learned in the previous section it's translated left 3 and up 4, so the vertex is negative 3, 4. It has a vertical reflection, so it's going to open down instead of up, and it's been stretched vertically by 2. Excuse me. If you look to the right, we have this graph. Vertex is at negative 3, 4, like we said. It opens down instead of up, and instead of going to the right and down 1, we're going to do twice as far down to the right and down 2. Instead of going to the right 2 and down 4, we would go to the right and down 8. That's because it's stretched vertically by 2. That's review from yesterday. So what is f of negative 4? Well, this means that we're going to take this function and we're going to replace the 2 in this problem with a negative 4. And then we simplify it using order of operations. Negative 4 plus 3 is a negative 1. Negative 1 squared means negative 1 times itself. Negative 1 times negative 1 is positive 1. Negative 2 times 1 is negative 2. Add 4 to that, and you're going to get 2. This means when x is negative 4, y is 2. F of negative 1. So we have our function, negative 2. Substituting in a negative 1, plus 3 squared plus 4. Now normally I don't use parentheses inside of parentheses. My typical mode is to change the outer ones to brackets. Some people get freaked out by that. But visually this is easier for me to comprehend than those double parentheses. Negative 1 plus 3 is 2. 2 squared means 2 times 2, which is 4. Negative 2 times 4 is negative 8. Negative 8 plus 4 is negative 4. This means when the x value is negative 1, the y value is negative 4. F of 0. So we're going to have negative 2 times the sum of 0 and 3 squared plus 4. 0 plus 3 is 3. 3 squared is 9. Negative 2 times 9 is 18 negative style. Add 4 to that, you get negative 14. When the x value is 0, the y value is negative 14. So here's one of those no-dot questions that you have to be able to answer in a clear, logical way. When you find the value of f of negative 4, the value of x equals negative 4. What does the result of f of negative 4 represent graphically? When we answer these questions, we're going to restate the question. So the question was, what does the result represent? We're going to say the result of f of negative 4 represents, we're going to include the word graphically a little bit differently here, but we're going to say the result of f of negative 4 represents the y value on the graph of f of x when x equals -4. Look how thorough this is. We restated the question. The result of f of -4 represents, we included graphically here, represents, so here's the answer, the y value, and it's specific which graph, the graph of f of x, that needs to be included, and when is this happening? It's happening when x equals -4. This is an all-encompassing answer. All right, let's check this out. The graph of f of x equals this parabola, and it's pictured. Do the results of f of -4 and f of -1 calculated previously make sense in the context of the graph? Explain why or why not. Well, f of -4 gave us 2. Let's look at our graph. When x is -4, is y the value 2? It sure is. So let's answer that. F of -4 equals 2, and f of -1 equals -4 makes sense. So I'm answering the question, do they make sense? Because on the graph of f of x, when x is -4, y is 2. So I'm saying when x is -4, y is 2. And when x is -1, y is -4. That's it. Once again, if you think, well, that's so obvious, we need to write down things that are so obvious. There's another one that you might hopefully find is pretty obvious. The graph of f of x has 2 zeros. Remember from Algebra 2 what a zero of a function is and define that term below. Well, if you don't remember it, we're going to define it here. A zero of a function is the x value when y is equal to 0. That's why it's called a zero. Graphically, this means the function is crossing or is tangent to the x-axis. So let me just show you real quick. Crossing the x-axis, it means like this. Tangent to the x-axis means that it comes down, gives it a little smooch, and then goes back from the direction it came from. This is tangent, this is crossing. The graph of f of x clearly crosses the x-axis at a value between -4 and -1. Let's look at that. So here's -4, here's -1. Isn't it obvious that it crosses someplace between there? Sure. Based on your computations above, how could you justify the guarantee of this occurring between -4 and -1? So the above calculations would be these calculations here. Well, here, the y value was above the x-axis. Here, the y value was below the x-axis. If your graph is continuous, and you have a y value above the x-axis and then a y value below, someplace between them, it has to cross the x-axis. That's basically what we're going to be saying here. Since f of -4 equals 2, the graph of f of x is above the y-axis because y is greater than 0. Since f of -1 equals -4, the graph of f of x is below the y-axis because y is less than 0. Notice the details in this. These details all need to be in here for you to get full credit on a test for a question like this. Therefore, this is the symbol mathematically for therefore, because the word therefore has too many letters for a mathematician to write. At some value of x between x is -4 and x equals -1, the graph must cross the x-axis, which guarantees 0. Based on the graph, we cannot determine exactly what the zeros of the functions are. According to the graph, between what pair of x values do the zeros of the function lie? Well, according to this graph, restating the question, which graph? graph of f of x, be specific, a 0 lies between x equals -5 and x equals -4. Now, how do I know that? It didn't ask me to say how, but I know that because I can see clearly, just with my eyes, it's crossing between those numbers. It's also crossing here. And another 0 is between x equals -2 and x equals -1. Previously, we took this function, same function we've been talking about the whole period here, and found values of y by substituting in x values. Now suppose we set the equation f of x equal to a and solve for x. When you solve the equation f of x equals 0, what do the results for x represent graphically? State the estimated values of x. So we got two things to do here. What do they represent? And we need to state the estimated values of x. The results of solving f of x equals 0 represents, restating the question, the values of x, could be 1 or more, when y equals 0. Remember we said at the beginning, f of x is the same as y, so it's saying y is 0. Looking at our graph, what would you estimate those to be? This one here, maybe -4.5, negative 4.4, it's an estimate. This one here, maybe -1.6 or -1.7. State the estimated values. X might be about -4.5, and x might be about -1.6. Estimated. You don't have to have the exact same answer. When you solve the equation for f of x equals -4, what do the results of x represent graphically? So let's just look at the graph when f of x equals -4. When f of x is -4, that is the y value. So when f of x equals -4, it represents what the x value is when the y value is -4. So let's write that down. Solving f of x equals -4 represents the x values when y is -4. State those values. So that would be x is -1 and x is -5. All right, moving on. For f of x, solve each of the following equations. Here we got f of x is 0. So we're putting a 0 in place of the y value. So we got our function -2 times the sum of x and 3 squared plus 4 equals 0. I'm going to subtract 4 from both sides of the equation, trying to get x by itself. And divide both sides by -2. This is all one term. So if I divide this by -2, it cancels this out. This is one term. If I divide it by -2, it's going to make that smaller. Then I'm going to square root both sides. Anytime you initiate the square root, you're going to write plus or minus. So it's plus or minus the square root of 2. We're not going to write rounded answers. We're going to leave it as an exact answer. So then x is going to be -3 plus or minus the square root of 2. In summary, when you evaluate f of a, what does the result represent graphically? The result of f of a represents the y value when x equals a. In summary, when you solve an equation f of x equals a, what does the results represent graphically? The results of f of x equals a represents the x value when y equals a. All right, we've got 4 more examples and we'll be done here. For each of the following functions, find the y value given the x value, or find the x value given the y value. Use the equation. So do this analytically using algebra, but then verify your result using the graph. Find the value of g of -6. Well, we're going to simply replace x with -6. We are trying to find the y value when the x value is -6. Absolute value bars mean whenever the calculation inside here is done, take the resulting number and make it positive. -6 plus 2 is -4. The absolute value of -4 is +4. -4 minus 5 is -1. So we are suggesting when x is -6, y is -1. Let's see if that's true. When x is -6, y is -1. That's true. Find the value of, for what value of x does g of x equal -4? Let me just copy this down real quick. So in this case, we are replacing g of x with -4, and we are solving this for x. This is going to serve as a good review for us, how to solve an equation in which the variable is inside the absolute value. Well, you want to get the absolute value by itself, so I'm going to add 5 to both sides. And then here's what we're saying. The inside of this could end up being positive or negative. But when you take the absolute value, it becomes positive. So the inside of this could equal 1, which in case would be super obvious, that's equal to 1. But the inside of this could also equal -1. Because if this was equal to -1, its absolute value is going to make it +1. Long story short, once you get the absolute value by itself, take the side without the absolute value bars and make it plus or minus. And remove the absolute value bars. And we're going to subtract 2 from both sides. We're going to get -2 plus or minus 1 is x. Now a -2 minus 1, Alexa, stop. Sorry, she piped in. I don't need her to. -2 minus 1 is -3, so we got x equals -3. And then we have -2 plus 1, which is -1. So x is -3. In another instance, it is -1. Let me change this to an or. And implies both happening at the same time, I believe. I don't want to imply that. Let's look at the graph. When y is -4, is x -3 and -1? -4, -1, -3, confirmed. All right, last equation, 2 more problems. Find the value of h of -1. H of -1, we're going to take and we're going to replace x in this with a -1. Make sure your square root covers over top of the 6 completely, but doesn't cover over any of the plus or the 3. -1 plus 6 is 5. Now, at this point, this is the exact answer. We're going to have a hard time looking at this in this form and saying, hey, when x is -1, y is clearly -2 square roots of 5 plus 3. You put this in your calculator, put it in all at once. In this class, we will always round to 3 decimal places. I cannot think of any exception to that. Should get -1.472. Can't tell for sure, but it sure looks like that could be -1.472. So that checks out. For what value of x does h of x equal -3? So we're putting -3 in for h of x. Now, how do we solve an equation in which the variable is inside of a radical? Just like the absolute value, you want to get the radical by itself. So I'm going to subtract 3 from both sides. It's going to give me -6 equals -2 times the square root of the sum of x and 6. And I'm going to divide both sides by -2. This is all one term, so that's going to cancel that -2 out. Once you got the square root by itself, then we are going to square both sides of the equation. On the left, we're going to get 9. On the right, we're going to get x plus 6. Therefore, we're going to get x is 3. So let's check. When y is -3, is x 3? Y is -3, x is 3. That checks out. Well, that concludes these notes. Please do the assignment as noted on the website.